Hi, chemistry students. Today we're going to do ternary ionic compounds. We've been doing binary ionic compounds, which means 2 elements, but ternary means 3 elements or more. So we're going to start by talking about polyatomic ions. Move this guy here. And sometimes a molecule forms that has covalent bonds within it, but it gains or loses electrons, and so it has a charge, so it's an ion. These are called polyatomic ions, and their names often end in "ite" or "ate". And here's a few examples. CO3 minus 2 is known as the carbonate ion. It's got carbon, and then the 8 ending tells you it's got oxygen too. It could bond with 2 sodium ions because it's CO3 minus 2. So here's a picture of it. You can see the carbon, the 3 oxygens, and then the 2 negative charges on it. And if you can picture another sodium ion coming in here with its +1 charge and another one over here, this would make a nice stable ionic compound. And it does. And the name of this compound is sodium carbonate. And the formula is Na2CO3. We always write the metal first. And there's 2 NAs, and then there's a C and 3 Os. Here's another example. This one is the phosphate ion. It's PO4 minus 3. It's got phosphorus and oxygen, so you know it's phosphate. It could bond with an iron 2 ion to make iron 2 phosphate. And to make the compound neutral, we would need 2 of those phosphate ions with their +3 charge, and 3 of the iron 2 ions with their +2 charge to make it neutral. And we have to use parentheses when we write the formulas for these. So the formula will be Fe3 parentheses PO4 parentheses 2. So the polyatomic ions that you need to know are these. There are 10 of them. You don't need to memorize them unless you're planning on taking AP Chemistry. If you do take AP Chemistry, you will be expected to know all of these, plus maybe a couple of more. I want to say cyanide is on there, which is Cn minus 1, carbon, nitrogen minus 1. But for general chemistry class, we're not expecting you to memorize these. You'll have a list given to you on all future tests, just like you're expected to be able to use a periodic table, you'll be expected to use this list as well. There are some interesting rules about the polyatomic ions that you do need to know, though. The base name for each ion that ends in 8, again, not all of them do, but there's a lot of them that do. It can be changed to form up to 3 more ions. So if the ending is 8 and then you change it to the ending "ite", then that has 1 less oxygen than the 8 variety. So "ite" means just like the 8, only with 1 less oxygen. If it starts with hypo and ends in "ite", then it has 2 less oxygens. If it starts with per and ends in 8, it has 1 extra oxygen. So it's kind of confusing until you see some examples, and they're really pretty simple once you know the rules. So chlorate is ClO3 minus 1. You don't need to memorize this. You'd be able to look it up on your list. But if you're looking for the perchlorate ion, you need to remember that per8 means 1 extra oxygen. So that's ClO4 minus 1. And you need to remember that chlorite, the "ite" ending, would be 1 less oxygen than the 8. So we go back up to the ClO3 minus 1, 8 version. And so chlorite is ClO2 minus 1. And then hypoite, remember, it means 2 less oxygens than the 8 variety. So hypochlorite is going to be ClO minus 1. So that's a little bit confusing. It'll take some practice, but you'll get used to it. So here's some practice problems for using polyatomic ions. They're really no different from using any other ion. In a binary ionic compound, it's pretty much the same. So let's go through some examples and see how we do. So we have, I'm going to pause for a minute here. Okay, so we have, for our first example, iron 3 chlorate. And so our cation is going to be, I'm sorry, that's iron 2 chlorate. So our cation will be the Fe+2 ion, and the anion will be the chlorate ion. So we're going to have to go back to our list and find chlorate again. And so if you go back Why can I not go back to the list? Okay, fine. If you go back and look at the list, you'll find ClO3 - 1 is the chlorate ion. And when you put those together, you got to balance the charge. So we've got +2 and -1, so we need 2 of the chlorate to go with the iron. So our formula will look like this: Fe parentheses ClO3 parentheses 2. Notice the 3 attached to the oxygen in the chlorate ion doesn't go anywhere. It doesn't change. That 3 will always be stuck to that oxygen. It's just a question of whether or not you put any parentheses and then a subscript out here. You don't do any math with the subscripts either. All right, let's try another one. Iron 2 sulfate is Fe +2, of course. And then sulfate, you're going to look it up because it ends in 8. Remember, if it ends in "ide," you just look on your periodic table because it's not a polyatomic ion. But if it ends in 8, then you got to look it up on your polyatomic ion list. SO4 - 2. So here we have a +2 and a -2, and they would directly cancel each other out. So we're going to not need any subscripts except for the 4 in the sulfate ion has to stay. So we'll have FeSO4. In our next one, we're going from the formula to the name. So first we're going to say, okay, it's going to be nickel something. Nickel's multivalent, so we may have Roman numerals. We will have Roman numerals. And then we have the PO3 polyatomic ion. So PO3, you're going to look it up on your polyatomic ion sheet, and you'll find PO4 - 3, which is phosphate. But this is PO3, and it'll keep its -3 charge because the charge doesn't change. So this is going to be called phosphite. So there's our phosphite ion. And then because we have one phosphite, PO3, bonding with one nickel, then we know nickel must have a +3 charge here. And so our name of our compound is going to be nickel, Roman numeral 3, because it's multivalent metal, and then phosphite. Nickel 3 phosphite. That was a tricky one. This one looks complicated as well. So here we've got CrO4 looks like a polyatomic ion. It's grouped in those parentheses, so you can look it up on your chart. And CrO4 is called the chromate ion, and it's CrO4 with a -2 charge. Now, tungsten is a multivalent metal, so figuring out what charge it has is going to be a bit tricky. But if you remember the crisscross thing, we're still doing that, and you can kind of go backwards here. We know chromate is -2 because we looked it up, and here's that 2. And then tungsten must be then +3. So the name of this compound will be tungsten 3 chromate. Okay, now we've got ammonium sulfide. Ammonium is a tricky one. It's on your polyatomic ion sheet. It's one of the only ones that doesn't end in 8 or ite. It's not obvious, so you just have to memorize. Ammonium means a polyatomic ion. And there's the ammonium ion. The sulfide ion, that's not an 8 or an ite, so it's not polyatomic. So we just look it up on the periodic table. Sulfur is in that -2 column, so there's that. And then we're going to neutralize the charge here. How many ammonium ions do we need to balance out a sulfur ion? The answer is 2, so there's our formula. Calcium carbonate. Calcium is a metal, and it's got a +2 charge. And then carbonate, that 8 ending tells us we got to look on the polyatomic ion sheet. So there's that. And we're going to balance our charge pretty quickly. Ca +2, CO3 -2 makes CaCO3. And on our last one, we have silver and nitrate. There's the nitrate ion from our polyatomic ion sheet. Silver must be +1. Now, silver is one of those few transition metals that's not technically multivalent, so we could write silver 1 nitrate or silver nitrate. Either way is fine.